All right. Welcome to the GROM's Rush Stream. Welcome. We had a little bit of delay today. Pushed came back 2 hours, so sorry to those that are watching this on video recording. But we're gonna get the stream recorded. And we're gonna get the video up on YouTube ASAP for everyone. Thanks for hanging in there. I am making probably a really bad mistake in drinking some sparkling water right before and while streaming. So if I go silent, it's merely to save your ears from hearing me burp. Today we're continuing our ride through the Rust book. We're working out of chapter 3. We're continuing chapter 3. This is the second stream on chapter 3. We'll be going through the data types section. We're going to be using Rustlang because I still haven't debugged my Rust instance in Visual Studio Code, see what's going on. But this will work for us. We're going to keep things. The code we write is going to be pretty minimal because we're going to be talking about a lot of like primitive concepts that are important to understand. So I was talking on Twitter today to a few people about my streams, and somebody with a background in embedded and object-oriented programming asked me if I recommended the books or to watch my streams. And I think that in general, like it's not an either or, right? The videos and streams are really my attempt to kind of learn the material better on my own by explaining it, but also provide some really good detail for beginners. So I think if you're a beginner programmer, you're the target audience for these streams. If you're an experienced programmer, you're more than welcome, obviously, to take part and ask questions and maybe even correct me on a few things. But I think that, if you're an experienced programmer, these words in this book generally make sense. But if you're new to programming, I think the book it's not necessarily friendly to the new programmer because there's a lot of words that, if you're not used to the words, they kind of take on a lot of cognitive load to understand. So if you read like one or two paragraphs, you know, they're all words that you're familiar with, but really understanding what they mean in the context of a programming language may not necessarily make sense. So we're going to talk through some of the data type stuff, and this, like I said, this is really fundamental to Rust. We may actually like kind of gloss over some of the information because I think some of this stuff is easy to get bogged down in. So yeah, I'm going to be kind of discriminate with that, but if there's anyone on the stream or even YouTube who wants to ask questions about that, I can either respond in chat or comments, or maybe we can even make a video later on or something. But yeah, so the data types are important, right? Because it's a really big part of programming in any language. Let me just bring the volume down a little bit on the music. In any language, data types are important, right? Because it really determines kind of what operators are compatible with that data type. In some instances, what methods can be run when you're what's the word? When you're passing your data into other methods and functions, it needs to be compatible with that function, right? And so a point that the Rust book makes is that Rust is statically typed. So whenever let's talk about this terms again. We touched on them towards the end of the last stream, but it's important, so I'm going to hit it again. So we really grok this idea of compile time and runtime. You can think of these as like two different phases of your program, right? Runtime is when your program's been compiled into an executable file, and it is literally like your computer is taking the information and instructions and running those instructions on the CPU or whatever architecture it's on. Excuse me. Compile time is when you have entered your code, and in the case of the playground, we click run, and that begins the compile time. But whether it's the command line and you do cargo build, or you can also do rust c space your file you want to compile, like we talked about in other videos. That's compile time, right? And so what it highlights, what the Rust book highlights, is that when the compiler goes to review your code, analyze your code, and turn it into instructions, it needs to know what every single variable, what kind of type it is. It has to know that in order for it to compile your code. It won't if there's ambiguity about that, or if it doesn't know what data type a variable or piece of data is, it's not going to compile. So they talk about that the compiler can usually infer based on the value, but that's not always going to be it's not always going to be possible for the compiler to infer that. So I don't know if we'll go deep into that today, into type inference, but just know that in some cases the compiler, without you being explicit and telling the compiler and actually typing it out what type it is, the compiler can make some assumptions about that type, but that's going to be limited. And in general, when it's possible, you're going to want to explicitly declare the type. Sorry, couldn't think of that word. So Rust talks about there's two subsets of data types. One is scalar and compound. Scalars are kind of like singular types of variables. Like different kinds of numbers, a Boolean, which is like a true or false, characters, and compound, we'll kind of look at that definition later. So let's talk about integers, right? Now, typically in um, in my experience, and I think that most people's experience using things like JavaScript and Python, you can just type in, like, let's say if we were, let's say if we were declaring a variable, um, you know, um, we would do something like this, right? We would just type int, because we, like in JavaScript, we generally, this int, this generic integer, is fine and works for us. But because JavaScript, or excuse me, because Rust is built with the idea of um, writing memory safe code, um, you have a lot more uh, granular control, or you are required to be more descriptive of the type of integer you want. Excuse me. So when we type an integer, we're just gonna. So this is an integer type, right? But there's multiple integers, and if you're looking on the Rust book in the chapter I posted in the chat, there is there's a chart of the different types of integers. Um, and so what I'm going to do is kind of break down this type so that when you see this type, you kind of know how to read it. And it's this looks probably a little daunting, but it's actually really simple. There's this first character that's either a U or an I, and that stands for either unsigned. The U stands for unsigned, and an I indicates a signed integer. And well, what does that mean, right? Um, so signs, if you've taken some arithmetic, um, you may remember negative numbers, right? Um, and that's all that means, is that a signed integer can have a negative sign. So with an unsigned integer, it is implied that any number that is a data type that starts with U, it is implied that that is positive. Okay. So these are the two options we'll see, either U or I. Let me just type this differently to number, right? And we'll do positive. And then, so I hope that's clear, right? If you're going to create a variable that needs to be able to, that it may not be negative when you first create it, so it's perfectly okay to say, let's just do this. Okay, so it's perfectly okay to have a assigned integer be a positive number. Okay. A unsigned integer, un32, can only be a positive number. Okay. U means unsigned. I is a signed integer. So why does that matter, right? Why can't we just have one kind of integer that is both? Like, why can't I just always have I32s, right? Why does there not need to also be a U32 option? Well, if you're a programmer, there's nothing stopping you from having all your integers be signed integers. There's nothing wrong with that. But as we work with Rust, like, memory safety and memory efficiency is important. And so with this granular control of an unsigned or assigned integer, the amount of the amount, sorry, the size of the data variable is different, right? Because when you create a variable, um, it reserves a certain amount of computer memory for that variable. And we want to be as efficient as possible with that. And we also want to like be aware of the size that we have to work with these integers. And that's why and let me just post this in the chat just because I haven't in a few. I recommend looking at this chart on the under the integer types section. That's why we also have these numbers after our u or our I, right? Because what that's telling us is how much, essentially how much data can be stored in this variable. So it's possible, let's see, let a small number, let's just see how this works, right? So there's a whole formula in a paragraph in the book that talks about this, that a U8, so an unsigned integer 8 of 8 bits, can store from 0 to 2 to the 8th minus 1. That's the range of numbers. Hey, Destin Blast, welcome. Good to see you. That 0 to 255 is a range of numbers you can store in a U8. So let's just test that out, right? So theoretically, this will not work. I'm just going to comment that out, just keep this simple. Right. So see, what this means is that the range of numbers that we can store in a U8 is smaller than 256. So let's do 255, because according to the Rust book, that is the upper cap of a U8. And this is just giving us a warning that we're not using it, which is fine. We can ignore that. But so we got a warning, but it still compiled, right? Because we just got a warning we didn't get an error. Let's go back and look at that again, the error state. Right? So so we have a warning. Let's get used to reading this compiler, right? The compiler feedback. There's a warning. What this warning is telling me that there's a variable here that I'm not using. I'm not doing anything with it. I declare it and then I don't do anything with it, which is fine. Like, there's ways we can get around that where we won't get a warning, but we're not going to mess with that right now. But more importantly is this error that's actually stopping us from compiling. See, our U8 that we declared will not contain this this variable because it's 256. Excuse me. I hope that makes sense. So there's some things here around integer literals that I think is a little bit too deep down the rabbit hole for us today. If I see a lot of chat or comments about this, I can go into it, but I don't want to these memory, these data type literals. We don't really need them for now. But there is a important paragraph just underneath the chart of table 32 that says, so how do you know which type of integer to use? And what it tells us is that Rust, if we don't declare the number, Rust will, or we don't declare the data type, Rust will infer the data type. Actually, this is a keyword. I don't think this is going to work for me. I think we have a problem here because I used a keyword. Oh, maybe it did. Yeah, it worked. Okay, so disregard that. So this just prints out the 43, right? So if you're just writing Rust to learn, it's perfectly okay to declare a variable like this, right? If we wanted to change the variable, the integer later, if we wanted to say, I'm going to change this to that just because it's bugging me. I think there may be some keyword I'm not aware of here that I'm colliding with. So if we wanted to just declare a variable without saying, excuse me. So if we just want to declare a variable without saying what kind of without saying what kind of variable it is, what kind of data type it is, what kind of integer it is, we can just do this, right? And then what's going to happen is that the Rust compiler is going to default it to I32. All right. Okay. All right. So if you're just learning Rust, it's perfectly. Here's what I would recommend. This is just my from the hip. Hey, Constructive Adventist, good to see you. Here's my tip. If you're just learning Rust, I don't know. We should have a little more fun with our variables, right? Excuse me. I think it's good to it's good to use data types, right? I'm gonna get those because otherwise I'm out of here. I'm just gonna get warnings. It's good to label our data types, right? So you can do this. It's good to kind of get in the practice so you know what you're gonna need, but don't worry about it. Like if you feel like if you're writing your code and you're struggling with something else, just declare it and let Rust handle it, right? I'm telling you that once it becomes apparent that you need to be aware of whether you want to use a U32 or a U8, right? Like you'll start to bump up against that, and the Rust compiler can give you errors, and chances are you're working in a place where you already know this. But for now, don't stress this stuff. It's good to be aware of because you're going to see a U32, right? You're going to see an I32, and you're not going to know why it's there, but hopefully now you know, right? So the next section in the Rust book talks about, well, actually there's like a highlighted section that talks about integer overflow. And this, again, I think like it's a little bit too much of a divergence for now. It talks about some differences between the behavior of integer overflows between compile time and runtime, which it's important to know once you're there. But if we're like a new programmer, we're learning. It's not. This is more cognitive load than I think we need right now. So the next, let me just get rid of some of these lines of code, right? And now we're going to talk about floats, which, if you programmed it all, I'm sure you're aware of floats. All floats are numbers. It's probably more, it's more appropriate to say they're numbers with decimal points, right? Like integer, you can say it's a whole number. that doesn't have a decimal point, I guess, and floats are numbers that don't have decimal points, or excuse me, do have decimal points. So 2.0 is a whole number, right? So if we were to say this is not a whole number, we'd be inaccurate. But anytime that this decimal space needs to be represented, Rust needs to be aware of that. So if you try to do, these two are not the same thing, right? This Rust is going to call this an integer, and Rust compiler is going to call this a float, because this .o on the other side of the number takes up space, and Rust wants to make sure when it creates this variable, it needs to use a data type that has allocated space for this, for these other characters in the number. And now when it comes to, these numeric data types we've been talking about today, there's some very simple, like, mathematical operators that if you've gone through arithmetic, you'll be familiar with what these do's, right? What these operators do. And they're very straightforward, right? There's no magic here. A minus sign subtracts, a plus sign adds, a star, that'll be your shift 8, will multiply or give you the product. A slash gives us it divides, right? And gives us a quotient. So we have an appendix here. Let me just pull that up in just a moment, and you can see. I'll get the link for that in just a moment. You'll see the. Sorry. And this is going to be a lot of information you don't need, again, but it's there once you need it. Rust has you covered. So we should talk about this because this was not. This is called a modulus, right? This is the sign. I'm just going to print this out just so you can see what this does. This actually becomes a pretty important operator as you become a programmer. So I'm just going to print out the remainder and leave these other variables out for now. Rust is going to give me the Rust compiler is going to say, hey, you have all these variables you're not using. One way that you can have Rust ignore those variables, the fact that you're not using them, is to prepend them with this underscore. That's just a FYI. I'll show you what that looks like in a moment. But for the time being, let's look at what this modulus does, right? So modulus actually gives us the remainder. And so we know 43 divided by 5 is 43 divided by 5 is 8. And then, 40 divided by 5 is 8. And it gives us the remainder of 3, right? Because 5 doesn't go into 40 more than 8 times. And so that's how you get the remainder. So I hope these are pretty straightforward. If they're not, obviously, like, you probably need to brush up on some arithmetic. Nothing wrong with that. But we're not going to spend a lot of time on them. All right. So I just want to touch on what happened here, okay? Or what I did here with these underscores. So Rust is very helpful, and it provides a lot of information. And if I'm creating a variable, in this case sum, and I'm not doing anything with it, I actually have 4 variables here that I'm not doing anything with, right? I'm only printing out one of them. Let me bring that up. So we have these 4 variables we're not doing anything with, right? And then this variable I am printing out right here. So something is happening to it. Nug Nug, what's up? Bring the meteor. Um, so Russ is going to complain at me that I have 4 variables here and nothing, and I'm not doing anything with them. It's going to be like, hey, why are you like? It wants me to be aware that I've saved this data in memory and nothing's happening, so that I'm aware that I'm doing that. But it's not going to stop me from compiling. So that's the difference between a warning and an error. So we have a couple of ways to address this. And the easiest one in this case is to just underscore, prepend an underscore, prefix an underscore to our variable names. And all that does is it changes the name of the variable, and it tells Rust that it can ignore the fact that it tells the Rust compiler that it can ignore the fact that it's not used. It's an unused piece of data. See, so now it doesn't give me warnings. There's other ways to tell Rust not to worry about it. We won't go into that today. And so next we have our Boolean type. I'm going to go pretty fast on this, pretty straightforward. It's all Boolean is true or false, right? And we'll work with this stuff really soon. In some ways, we've kind of already worked with that with our match statement and our guessing game. We've already worked with Booleans behind the scenes, but it's just, I don't know how to explain it, right? It declares a state of true or false, and what happens typically is in your code you'll use this as a logic gate to determine if something's happened or not. Yeah. And then we have the character type, which is our individual characters. And a fun thing about Rust is we can, let's do something fun here. Quote unquote fun. Give me just a moment. So Rust is a new tool set. It's a new language, relatively new, and it's being updated. And obviously, if Rust was written like, what's the word? If Rust was written like, sorry, I'm trying to do 2 things at once, and I never do that very well. If Rust was written in the 80s, when all we had was black and white terminals or green and white terminals, it just wouldn't work. But now, like, the world is upgraded and we have emojis as standard in the keyboard, so Rust is actually taking advantage of that. And so one of the things we can do is use emojis in our code, which is kind of cool to me. Maybe it's not to you, but I think it's cool. And I'm going to get complained at because I don't have prepends here, but now they won't complain me. The compiler won't complain me. And now we're sending a surfer to the standard output. That's pretty awesome, right? Maybe not. I think it's cool. Because there's a long time where this would have been kind of unimaginable. Like you had kind of like the boring text as your options for your code and stuff. But yeah. Paragraph in the Rust book. It tells you that the character is 4 bytes in size and can represent more than just ASCII. It can represent a lot of different surfing the terminal exactly, that's a blast. we can do like different languages, all the different accents that we see in other languages, um, and emojis are one of those things. So that's cool, right? I mean, maybe it's not. um, yeah, very cool. Makes waves of code have a new me. That's right, Master Dojan. um, yeah. So that is all the scalar types we're going to go into. And next up is compound types. And I think I'm going to get a bit of a preview, and then we're going to call it. We're going to call it today, right? Because like this stuff here, it's kind of boring in some senses, right? We're learning about what is a number, what is a character, what is, we can do math with them. Oh, awesome, right? But it's all very fundamental and important to becoming a programmer, and especially a Rust programmer if you want to work on systems level programming. A lot of the audience here are interested in learning Rust. They can program the Solana blockchain. Numbers are important, right? Once we start moving tokens around the blockchain, or if you want to get a DeFi, all this, what your numbers do, like what they're capable of, the things we talked about with integers, how certain integers can only contain a certain range of numbers. It all becomes very important. So I'm gonna break this here tomorrow. Not tomorrow. Next week we're gonna pick up compound types. I encourage you to work ahead. And basically, like compound types are just like multiple pieces of data in one variable, right? So we have arrays and tuples. We'll talk about what those are. You'll learn about them. They're important because grouping information together will also be important in your programming. But yeah, I think that's it for today. I'm glad we got to print a surfer to the standard output. That's pretty awesome. I'm working on a new streaming setup. Hopefully, I'll have that in time for next week. But if not, we're going to make it do, and we're going to keep moving, learning Rust. All right, everybody. Thanks for rolling with me. I'm going to post all our links to our YouTube, our Discord. Actually, I'm just going to show those. Right? Oh, that doesn't work very well. Let me just grab these and grab these links for you guys. Hang on here. Here's what I'm gonna do. I'm gonna give you the Twitter, because from there, you're welcome, guys. Thank you, Blast. Thank you, Master Dojan. You're welcome. Thank you for being here. From our Twitter, you can go mint to GROM. You can join the Discord. Most important thing, right? Get in the Discord and come learn Rust with us. We'll be getting some more of these going. Hopefully, after the new year, we'll have a more regular schedule and have more frequently. And hopefully, I can just start jumping on here and going through some Solana stuff too. That's kind of my goal. We'll also be doing some exclusive Solana stuff in the GROM's Discord for GROM's holders eventually. So consider getting a GROM if you don't have one. All right, y'all. Peace out and ride the terminal. Gnarly.